there's much discussion about this problem from the homework. As I was telling a few people before class started, it's all in my grand plan to, in most of your homework assignments, give you at least one, maybe sometimes two problems where I didn't show you how to do that kind of problem. Okay. Yet, you have all the information you need to solve it. So I taught you about the Borda method, which is what this question's about. You know exactly how the method works. And now I want you to try to take what you know about that method and answer a new kind of question that I didn't explicitly show you how to do. So that's part of the idea behind this particular class. Is called mathematical problem solving, right? So you should be able to look at a new kind of problem and try things and get the wrong answer and try something different, and that's part of the process. Okay. This is from the homework. It's not in your packet. This is number 6 in your most recent homework. Yeah,
From the 1-3, number 6.
1 1 1 2 1 3 number 6. So my general philosophy here is that I am gonna make I want you to struggle. And it's okay if you struggle for a while and don't get it. This struggle is something that I want you to get comfortable with, because that's what problem solving is. Struggle till you get it, right? So I want you to struggle with them a little bit, and then if you still don't get it by the day it's due, I'll give you some hints. And so your homework is due tonight at 11:59. So I'll give you a little hint here. So we have a certain college football poll ranks the top 29 college football teams, and they're ranked using the Borda count method. That's the one where you assign points based on the place. So there's 29 teams, which means a first place vote gets 29 points. Second place vote gets 28 points. Third place vote, 27 points, and so on. So last place gets 1 point. So this table shows the rankings just for the top 3 teams. And it says the remaining 26 teams aren't shown because it doesn't matter. You don't need that information to answer the question. All right, so part A was college A is the unanimous first place choice. Okay, so that means every single voter ranked college A first place. How many people participated in the poll? So every voter put them in first place, put college A in first place. So every voter gave college A 29 points. So the number of voters times 29 points each should give you how many points? 1,856. That's the total number of points that college A got, right? So knowing this, could you figure out how many voters there are? Yeah.
64.
64. Divide both sides by 29.
Yep.
Okay, so let's put that in so we can get part B here. Check answer. Oh, good job. Thank you. All right, I'll take a picture of this. All right, given that all the voters had college B in either second or third place, which means they got either 28 or 27 points from everyone. Every single voter gave them either 28 points or 27 points. Okay. Find the number of second and the number of third place voters for college B. Number of third place votes for college B. So that's the total number of points college B got, right? So they got a bunch of 28s and they got a bunch of 27s, because some people put them in second, some people put them in third. So we got a bunch of 28s, right? Some number of people put them in second. So that number of whoever put them in second, they each gave 28 points. So you could multiply 28 times the number of people that put them in second. And then a bunch of people gave them 27 points because some people put them in third. 27 points times some number of people, right?
So the number of peoples are going to become an n.
Yeah, so these are the things they asked us about. They said find the number of second place and the number of third place votes. That's this and this, which we don't know. But we do know how many points total we should get from doing this, right? Because we know that team B got 1756 points altogether. Okay. Now these two numbers are related to each other, knowing what you know from question A. Total number of people who voted was 64. All right, so dun dun dun. I'm going to use a little algebra here. So 28. These are two things that we don't know, right? What do you call a thing you don't know in math? X or n, yeah. So let's call one of them X. So the number of people who put college B in second place, we'll call that X. All right, and then the rest of the people must have put college B in third place, right? If X people put them in second, how many people put them in third?
However many people minus x.
Yes, however many people is 64. 64, the rest of the people had them in third. So the total of 64, subtract the people who put B in second place, and you get 64 minus x. So now you have an equation you can solve. So that's an equation you would have learned how to do in a previous algebra class. Distribute the 27, combine the like terms, and you should be good. All right, so those are some pretty big hints because that was your first tough problem. I won't be quite as generous in future hints. And I'm going to leave part C for you to think about. All right, any other questions? Things you want to talk about before we start? Okay. Okay, so class 3, we're going to talk about some logic, which is just going to be like, it's going to not even feel like math. It's going to feel like English class, being really precise in our meaning when we speak. But before we start, you should note that the first project is now officially assigned. Okay, so you should have, if you got your ballot to me on time, you should have received your ballots back last class, right? So I gave you a pile of ballots, and you have all your data. Okay. If you haven't gotten any data from me, just collect your own data. Make up a question with 4 choices, and go around and ask 20 people for their preferences. And then you use that material to answer all the questions in project 1. So let me actually just open up project 1 so we can talk about it a little bit. Come on. Okay, so these are the steps of project 1. Devise a vote where at least 20 people choose from among 4 options. So many of you have this done because you did it in class, right? And part B, conduct the vote. Done. Part C, this is where you start doing the stuff that we learned in class. Take all your votes, take all your ballots, and summarize them into a preference schedule on the back of this page. So you should, tell me the total number of voters, tell me what your 4 options are, and then you make a preference schedule, just like all your homework problems have. All right, then figure out the complete ranking according to each of the 4 methods. We now know all 4 methods: plurality, Borda, plurality elimination, pairwise comparisons. And there's a space for you to do these in this packet. Okay, so right after the preference schedule, Number 1, show all your work for doing the plurality method, and then put your answers down in the blanks here. And there's a page for each method. Come on. There's some space to do the Borda method and a place to put in your answers.
Do you want like a graph right up there in that space, like the ones on the front page?
You only have to do that once. Yeah, so you can refer back to that. If you prefer to have it rewritten, that's fine, but you don't have to. And then after you do each of the 4 methods, that's weird, okay. Plurality with elimination and pairwise comparisons, then there's a few questions that you have to answer about your project. So you just fill that in and you're done. Not too bad a project.
The ballots, I didn't get any of the ballots. I sort of did them on
Okay.
Can I ask you a silly question?
Sure.
Because it's asking us about the majority and the criteria, anybody like making a violation of that. My only thinking is I understand what the majority is. You have to have 1 plus whatever it is.
Yeah.
But how is it that it could be violated?
Okay, so
that's kind of like not forming up.
So for the violating or satisfying the various criteria, that's what we're going to talk about today, about what those criteria are.
I can't answer
Okay.
this.
Okay, so the material in this section is a little tough. Be patient with yourself. Expect to struggle with the new vocabulary and ideas at first. Okay. We're going to start by making sure we have a clear understanding of if-then statements. So suppose I want to stick to an exercise regimen and I follow this rule. And in fact, this is a rule that my trainer gave me, right? And if I don't follow this rule, I'm in big trouble. Okay. If the weather's okay, then I will go outside and go for a run in the morning. If the weather's okay, I will go for a run. All right. So either the weather's okay or it's not, and either I go for a run or I don't. So there's 2 pieces to this statement, the if part and the then part. The if part is either true or false. The then part is either true or false. Okay. Let's look at each of the 4 possibilities of how I can combine which things happen and which things don't. All right. A, the weather is okay and I go for a run. Am I going to get in trouble with the trainer? No, I did exactly what she said, right? She said, if the weather's okay, I have to go for a run. I'm not in trouble. If the weather's okay and I don't go for a run, am I in trouble? Yes, I'm going to be in big trouble here, right? I broke the rule. How about if the weather is not okay and I go for a run? Am I going to get in trouble with my trainer?
No.
No, that is extra training, right? I'm not going to get in trouble for going for a run when I'm not required. Does that make sense? So the weather is not okay and I still go for a run, that's cool. I didn't break the rule. The rule is if the weather's okay, I have to go for a run. Okay. How about if the weather is not okay and I don't go for a run?
That's fine.
Also fine. Yep. So there's only one way to break the rule. There's only one thing that could happen of the 4 possibilities where the rule has been violated. And that is if the weather is okay and I don't go for the run. Make sense? So we're being very precise in the meaning of an if-then statement. There's only one way to make an if-then statement false or to violate the meaning of an if-then statement. Okay. So the only way an if-then statement is false is if the if part is true, right? The weather was okay, the if part was true, and the then part was false, right? I should have gone for a run and I didn't. All right, so let's go back to the analysis of our elections. For a completed election to be considered fair, it has to meet certain criteria. The first and most basic expectation is the following. It's called the majority criterion, and it says if candidate X, that's whoever, Susie, right? If candidate X has a majority of the first place votes, then candidate X should win. So if somebody gets more than half the votes, we think they should be the winner. That's a basic measure of fairness. It would be weird, right? If somebody had more than half the votes and the other person won. So this is one of our basic measures of fairness.
Which could happen in a presidential election.
It can happen in it.
Yes, it can.
Okay, so it's possible for someone to win without a majority, but is it possible for someone to get a majority and lose?
Yes. Yes. Because the electoral college and the people are two different things.
Ah.
And it's voted on by the electoral college, not the people.
You're right. You're right. Thank you
So
for
electoral
reminding me.
college says, I'm going to vote in for him.
Yes.
And we say we want him, then he's going to be president, not him.
Yeah,
Which absolutely is a
yes, so
violation, but-
yes, with the electoral college, you're right. It is possible for someone to win a majority of the popular vote and lose the overall election. So that would be considered a violation of the majority criterion, which is our first most basic rule of fairness. Okay. So it is possible in a presidential election. All right, so let's look at a simpler example than the presidential election.
Okay. I'm sorry.
No, that's okay. It's a good thing to point out. That was great. Okay, so how many people voted in this election? 7, which means how many do you need for a majority? 4. Does anyone have a majority?
Yes.
Yes. Okay, so candidate A has a majority. Okay. Now, I want you to take a few minutes, because this is also a good review, determine the winner of this election using the Borda count method. This is the method with the points. First place gets 4 points. 3, 2, 1. Okay. And then every ballot that has a candidate in first place gives 4 points to that candidate. So if you look at this first column with the 4 at the top, that represents 4 separate ballots that all look like that. So for each of those 4 ballots, we should give A 4 points. So that's 16, right? So I like to just put the little numbers right next to it and then add them up later. And then for each of these 4 ballots, we should give 3 points to candidate C. So 12, 8, and 4. So really a quick procedure is that you just multiply points times the number of ballots. So 4 times 2, that's 8. 3 times 2 is 6. 4, 1, and then 2, yeah. 4, 3, 2, 1. All right, so then you add up all the points that are next to A. So A's got 16 plus 2 is 17. 16, 18, 16, 18, 19. Yeah. Okay, and then B, we've got 8 and 6 is 14, and 2 is 16. And C has 12 plus 8 is 20, 24. And D has 4 and 4 is 8, and 3 is 11. So who wins the election?
C.
C. Good.
A. Sorry, A wins
Why does A win?
because he had the majority.
Doesn't matter if we're using Borda method. If you use Borda, C is the winner. But there is this weird thing though, right? A majority of the people, more than half of the voters, wanted candidate A, but candidate A lost to candidate C. This would be a violation of the majority criterion. Okay, A had a majority, so that satisfies the if part, right? But A didn't win. Okay, that's the then part. A should win if they have a majority. So according to the majority criterion, this isn't fair. We say that in this election, the Borda method violates the majority criterion. Okay. So below are, I've written down 4 possibilities for the truthiness. Did you guys watch Colbert? So the truthiness of the if-then statements of the majority criterion. Okay. One of these 4 statements should feel unfair. So circle the statement that would indicate a violation of the majority criterion. So B is the only one that feels truly unfair, right? If candidate X has more than half the votes, you say a majority of the people want me to win, but you lose, right? So if you have a majority and you lose, this is unfair. All the other ones, well, maybe not ideal, they don't have a fairer alternative, right? So candidate X has a majority and candidate X won, ideal, right? And then the other two, no candidate gets a majority, right? So the majority criterion doesn't say anything about who should win in that case, right? If no one has a majority, we just have to decide the winner the best way we can, right? So the majority criterion has nothing to say here. It only says that if someone has a majority, they should win. Yeah.
So from what we've done, Borda is really the only method that would disallow that from happening, provided that that was the agreed upon status prior to the election.
So from what we've seen, Borda is the only method that we've seen has the possibility to violate this criterion. It doesn't always violate it, just it has the possibility that it sometimes can. And other methods might, we haven't investigated very far yet. In fact, let's think about one other method, like let's say the plurality method. Is it possible for someone to get a majority of votes in the plurality method and lose?
No.
Yeah. The plurality method is just the one where the person with the most votes wins. And if somebody has a majority, that's more than half, that will also be the most, because there are less than half left to go around among the remaining candidates. So it's impossible to violate the majority criterion in the plurality method. But in Borda, you can. And maybe you should think about it, about the other two methods, and see what you come up with. But before we start investigating that further, we're going to do one more criterion here. This one is called the Condorcet Criterion. Condorcet was the name of a mathematician who came up with this. It says, if candidate X is preferred by the voters over each of the other candidates in a head-to-head comparison, so like when we do pairwise and you pair everyone head-to-head, if there's a candidate who wins all of their matchups, who never loses to anyone else, we call them a Condorcet candidate, and they should be the winner of the election. So here's an example where we'll see a example of the Condorcet criterion in action here. So Tasmania State University's marching band, they've been invited to perform at 5 different bowl games. And the results of the voting by the 100 members of the band are in this preference schedule. So if we use the plurality method, most first place votes, which bowl game are we going to be performing at? The Rose Bowl. R is for Rose Bowl. So Rose Bowl has 49 votes. The Hula Bowl has 48 first place votes, and the Fiesta Bowl has 3 first place votes. So the Rose Bowl wins using plurality. Is there a candidate who will beat anyone else head to head?
Yeah.
Who? Hula, yeah. Hula is ranked first by these 48, right? Everyone else has him in second. So let's try matching Hula against everyone else head to head. So if I do Hula against, say, Rose Bowl, okay, Hula would get 51 votes, right? These 48 would choose Hula, and these 3 would also choose Hula because they have it ranked above Rose. So we'd have 51 for Hula, 49 for Rose. So Hula wins that matchup. All right, let's do Hula against everybody else. Hula versus Fiesta. Hula would get 97. Fiesta would get 3. Hula versus Sugar Bowl. Hula would get all of them, right? Everyone has Hula ranked above the Sugar Bowl. So 100 to 0. Hula versus Orange Bowl. 100 to 0. Everyone has hula ranked above orange. And then that's 1, 2, 3, 4. That's all 5. Okay. So hula wins every single head-to-head matchup. They are undefeated head-to-head. That's what it means to be a Condorcet candidate. Okay. So yes, hula. So thus, in this election, the plurality method, the method we use to determine the winner, told us the Rose Bowl would win. But we had a Condorcet candidate, hula, who's preferred over every other candidate head-to-head. So the plurality method violates the Condorcet criterion.
So are things like that like agreed upon before the election even occurs?
No. So basically what we agree upon before the election occurs is the method. And when you agree on a method, you accept the method, possible flaws and all. So even though it might, if we say we're using plurality, even if it happens that Rose Bowl wins and that seems unfair, we already agreed on plurality, right? For that particular method. You might propose a change and say, I don't like plurality anymore. Let's switch to Borda, but you can't change this election, right? Just because you didn't like the way the method produced a winner.
Right. So for the particular election, that's agreed upon beforehand.
Yes, the method is agreed upon. That's what we're going to do. And even if the results come out feeling unfair. All right, so here are 4 possibilities for the truthiness of the if-then statements using the Condorcet criterion. One of them should feel unfair, and the rest should be okay. So see if you can decide which one is the unfair method. Sorry, the unfair outcome. Yeah, so in B, candidate X beat every other candidate in a head-to-head comparison. So think of that as like undefeated, right? You have an undefeated candidate. They should win the election, right? So in this case, good, they did win the election. Ideal. Okay. If candidate X beat every other candidate in a head-to-head comparison, so they're undefeated in head-to-head matchups, but then they,
I think you
oops,
got the X
sorry,
wrong place.
I do.
I was going to say that didn't
This one's ideal.
Yeah.
They're undefeated and they win. That's great. But if you have a candidate who beats every other candidate head-to-head, so they're undefeated, and then they lose the election, that's unfair. That feels unfair. And then the other ones, there is no Condorcet candidate, right? If there's no candidate who is a undefeated candidate in their head-to-head matchups, then this criterion says nothing about who should win in that case. We just have to determine the winner using our method, and this criterion, talking about Condorcet, they don't care who wins. They only care that if somebody is undefeated, they should win. So if there's no undefeated candidate, you can't violate this criterion. It's just like if the weather's not nice outside, I can go for a run or not go for a run, not violating the rule. All right, we have another one. Third fairness criteria. It's called the Monotonicity Criterion. So monotonicity, the root of the word monotonicity is like mono, one, all the same, like monotone. Okay. So it says, if candidate X is the winner of an election. All right, so we ran an election, we have a winner. And then in a re-election, for some reason we have to have a re-election. The only changes in the ballots are changes that are good for candidate X, right? The only changes involve some voters ranking X higher on their ballot, and they don't change anything else. If this happens, candidate X should still win. That feels fair, right? No? So let's say I won an election. You guys all voted and I'm the winner. And then we have to have a re-election, like maybe I lost the ballots. I accidentally burned them or something, right? So I have to redo the election. You all have to refill out your ballots. And then the only changes that maybe a handful of people say, you know, I like her a little better than I did before. I'm just going to move her up a spot, right? And those are the only changes. They're good changes for the person who won before. So maybe I'm ranked a little higher by some people. And then I recount the ballots. I should still win. Okay, and if I don't still win, that would be weird. Okay, so that's what this says. That's
only if the people that change their mind rank too high.
Right. Only
too lower.
Yes. Then this does not apply. Yeah. Only if those people ranked me higher. All right. So here's an example where we can see the monotonicity criterion at work. So I'm going to have you work through A and B and C. Just work through the whole thing in your groups. I'll come around and give you a hint if you need it. All right, we're going to use plurality with elimination to determine the winner. So again, this is to summarize. 3 cities, Athens, Barcelona, and Calgary, are competing to host the Summer Olympics. The final choice is made by plurality with elimination by the International Olympic Committee. And this is real. This is how they choose the city. So 2 days before the actual election is going to be held, they do an unofficial straw poll of the members of the IOC just to see how things stand, see who's leading the race, who's likely to win. So these are the results. So we do a quick calculation, plurality with elimination. And to do plurality with elimination, you have to know what a majority is, because that's how you know when you're done. So there are 29 voters here, which means we need 15 for a majority.
29, yeah. 29 is 14 and a half.
Yeah.
So as long as you're at 15, you're about there.
So now let's count first place votes. So A currently has 11, right? These 7 and these 4. B has 8, and C has 10. Does anyone have a majority? No. Okay, so that means you get rid of last place. So B is in last place, right? So we get rid of B. Who should I give B's 8 votes to? C. You look to the preference schedule. These 8 people wanted to vote for B. We have to honor that these are their votes, right? If we say B is not in the running, B, you have to choose somebody else. We know that they would choose C because they have C ranked in next place. So I'm going to give those votes to C. 18 votes is a majority. C wins. Right, so Calgary's going to win the election.
Now, we're going to go to the part that I want to.
Yeah. Okay, so now the results of the unofficial straw poll were supposed to be secret, right? Only the chair of the committee or whatever is supposed to know the results. But the results leak out, and since everybody loves a winner, the delegates in the 4th column, those 4 people in the 4th column who had Athens in 1st and Calgary in 2nd, they're going to jump on the Calgary bandwagon and say, you know what? We want to say that we voted for the winner, so we're going to vote for Calgary. So I'm going to remake the preference schedule, just changing these 2. So we're going to have 7 still goes ABC, 8 still goes BCA, 10 CAB, and these last 4 now are also going to be CAB. So if I wanted to, I can combine these into a single column that says 14. Doesn't really matter. You can leave it as 2 if you want.
Okay, now they increased their vote for the win.
Yes. So the only changes in the ballots here were positive changes for Calgary, right?
Right.
4 people decided to move Calgary from 2nd to 1st.
Okay.
So it still is 50.
Violation to the monotonicious, whatever.
Well,
It's not,
so
it's not,
the
it's not a
the-
monotone one. It's not a violation, right?
the if part is true, right? So the if part is true. We're having a re-election and only positive changes for Calgary have occurred. So now, if Calgary doesn't win, we will have violated the monotonicity criterion. All right, so let's count first place votes. A has 7, B has 8, C has 14.
So get rid of A and then
A now has the fewest first place votes. Who should they go to? They should go to B, right?
B wins.
And now B wins with 15 votes. So that is weird, right? So Calgary won the straw poll. 4 people just decided to jump on the bandwagon. They just said, oh, you know what? Calgary's good. Yeah, we'll vote for Calgary too. And then Calgary lost.
Maybe that was part of their plan.
So this is an example of a violation of the monotonicity criterion. Oops. So to summarize, Calgary wins the unofficial vote. A revote happened, and everyone kept their votes exactly the same, except a few voters who moved Calgary higher. And then, surprisingly, Calgary loses the revote. So in this election, the method we did was plurality with elimination, and it violates the monotonicity criterion. All right, we have one more, final one. It's known by a couple of different names. We can call it the independence of irrelevant alternatives criterion, also known as IIA for short, or the or the dropout criterion. All right.
Drop out, that's good. Oh, I got one.
This
That's my vote. I'm just saying, we're voting here.
This is another criterion that deals with having to do a revote. But in this one, we have to do the revote because somebody drops out or is kicked out, disqualified. So this says if candidate X wins, so we have done an election, we have a winner, right? And then one of the non-winning candidates has to withdraw or is disqualified. Then if we recount the votes, X should still be the winner. Right? It shouldn't matter that one of the non-winning candidates was disqualified after the fact. So let's see if we can do an example that illustrates this. It's time to elect a mayor in Greenfield. It's a very small turnout at the polls.
I guess.
Who wins this using the plurality method? A. A has 3 votes, C has 2 votes, B has 2 votes. So, hold on. So A wins, right? After all the votes were cast, but before the votes had been counted, the people who count are very slow. A scandal involving candidate B comes to light, and candidate B decides to immediately withdraw from the race. Okay. Since the votes have already been cast, the election is officially completed. It wouldn't be fair to the candidates or the voters to spend the money to have a revote, right? To make everyone go back to the polls and vote again. Okay, so all we have to do is cross B off of all the ballots, right? So if I just go back up here and I say B is gone, so cross B out and move everyone up a spot. So this now would be D and this would be A. B gets crossed out and this is now C, D, A. That makes sense? And if this gets messy to you, feel free to rewrite the whole thing. In fact, I do it all the time because I'd rather spend time writing everything down than making a mistake and starting over.
Be okay just to cross it out?
Yeah, it's okay to just cross it out, yeah. So now we have ACD, 3 ACDs, and then the other 2 columns, the 2 and the 2 are both CDA, so I'll just combine those into a single column. All right, so since B is gone, now we determine the winner. A has 3 votes. C has 4 votes, and C wins now. So A was our winner. A non-winning candidate, B, drops out. And now C wins. Yes.
Wouldn't that kind of be okay since if there was no B, then we would see it?
Yeah, it's not necessarily bad. It's just strange. Yeah, it's just weird. So it seems that we asked people to choose and they chose A, right? We asked the people to vote and they chose A as their next mayor. And then B, who was not the chosen mayor, right, says, never mind, I don't want the job. It's like, well, good, because you didn't get it, right? But then just because B dropped out, now we want C. So this election, we just did the plurality method, and we saw that it violates the I, or dropout. I like dropout because it reminds you of when this comes into play because somebody dropped out or was disqualified or eliminated, whatever. So all 4 of these fairness criteria that we talked about today are on page 9 of your packet, summarized there. This is a brief summary to determine if there's a violation. Okay? So for the majority criterion, the only way to violate it is if a candidate has a majority and loses. Okay? For Condorcet, the only way to violate it is if you have a candidate who's undefeated but loses. Monotonicity, the way you violate it, these last 2 are a little bit more complicated. Okay? So the way you violate this one is if you have a candidate who wins the election but doesn't win a re-election if only positive things happened for them on the ballots. And IIA is a candidate wins an election, an irrelevant candidate drops out, and then you have a new winner of the election.
So those are the violations.
These are the violations. These are the ways, the only way to violate these 4 criterion. Anything else is fine. These are these are the violations. Okay, so I would like you to get started on voting activity number 3. And I will be around to discuss and help if needed.